In this video, we're going to look at a little bit more difficult example of converting a quadratic in general form to what is known as vertex form, or the standard form, a times the quantity x minus h squared plus k. And then we'll talk about identifying the vertex from there. We're going to use a technique called completing the square. So the first thing we want to do is group our terms. Y equals 3 times x squared plus 5x, and then we'll have the minus 6 at the end. And we'll talk about what's going to happen in this space. Now the next thing, if there's ever a coefficient on x squared, we need to get rid of that. So what I'm going to do is I'm going to factor 3 out, but I'm only going to factor it out of the first two terms. So 3 times the quantity x squared. Now if I factor a 3 out of here, that'll leave me with 5 over 3 times x. Because if you imagine distributing the 3 back, 3 times 5/3 is 5. Now once again we're going to add something and we're going to subtract something. And we're going to do this whole one in fractions, but it could have just as easily been done in decimals. Minus 6. I think fractions are a little easier to work with. Okay, now we go to the next step, which is y equals 3 times the quantity something squared, and this will always be x. And then we go to what we were looking at last time. The sign here is determined by the sign here. The number that goes here is exactly half of this number. So 5/3 times 1/2 is 5/6. That also tells us what goes here and here. Remember, it's this number squared that goes here and here. So we have a 5/6 squared there, and also 5/6 squared there. Alright? Now we do need to bring down the rest of these numbers. This part right here is done. The 3 went here. This is our perfect square. We still have the minus 6 at the end, and we now have another number. And this is where you got to be a little careful. It is going to be this negative 5/6, the quantity squared, but notice it's inside this set of parentheses here. So it does need to get multiplied by the 3. So in doing so, it's going to be negative, and then there's going to be the 3 times the 5/6 squared. Now we can begin to put this thing together. So y equals 3 times x plus 5/6, the quantity squared. There's our completed square. Now we have to take care of the leftover that we introduced. So 5/6 squared is 25 over 36. 25 over 36 times 3 is going to give us 75 over 36 minus 6. Okay, so we're dealing with fractions. We will be able to reduce that a little bit. So 3 times x plus 5/6 squared. And we'll go through all the steps just so we don't miss anything. These have a common factor of 3, so this will reduce down to 25 over 12. And let's make this a fraction. We're going to need common denominators. So we got to give 6 a denominator of 12. Recall how we do that. We multiply this by 12 over 12. So that's going to give us 72 over 12. Both of these, in fact, are negative. So 3 times x plus 5/6, the quantity squared, minus 97 over 12. And we have now converted to standard or vertex form. Notice it's got the same a value as our original quadratic, which is 3. Positive a value tells us it opens up. The larger a is, the wider our quadratic is. So that gives us the same piece of information. What's useful about the vertex form is we can look at this as the graph of y equals x squared going left by 5/6 and going down by 97/12. So in identifying the vertex, it's just a shift left of 5/6. So the x-coordinate of our vertex would be negative 5/6, and a shift down of 97/12, so negative 97/12. Notice when we pull out the vertex, it becomes, we change the sign on the inside, but not on the outside. So when you're pulling the vertex out of your vertex form, remember, change the sign on the x-coordinate, but not the y-coordinate.